Good morning. My name is Xavier Ducrohet. I'm the lead for the Android SDK and developer tools, and I'm the main contributor to the new build system for the SDK. So why a new build system? Well, if you look at the current situation, on one hand, we have some Ant scripts that are somewhat customizable, although we have no public API for it, and it's likely to break whenever we update the SDK. On the other hand, we have ADT, custom builders, very rigid, but at least it works in the IDE, right? And then we have IntelliJ that has its own builder that does, it's a bit more flexible, but doesn't do manifest merging, some issues. So we wanted to fix that. We wanted to create a single build system that was very flexible so that it adapts to all of your needs within reasons. And that we wanted that build system to work whether you're building from your continuous integration server or within the IDE, right? If your customization doesn't work in your IDE, then it just doesn't work, it breaks your workflow. We wanted to add some features like dependency management, the ability to deploy and run tests, but also Android-specific features that developers have asked us. We didn't want to start from scratch, so we looked around. There's a lot of build system out there. They have plugin ecosystem, support in Jenkins, TeamCity, and we wanted to leverage all of that. So we looked around, and we settled on Gradle. So why Gradle? Well, as a user, it's very powerful, great declarative syntax, but you can customize to your need, and it has a great tooling API to do IDE integration. From our point of view, when we develop the plugin, we can create a new domain-specific language to really, make the configuration of the build system very specific to Android. We can expose great APIs for you to extend the build system. And the IDE integration can be customized so that the IDE really knows not just about, hey, just some sort of build system, but it's really an Android build system. It's also developed by a company called Gradleware, who does that in open source. It's Apache, so that's great for us. And we've worked together to make sure that the build system Gradle itself is adding features specifically that we need so that we can give the best possible experience to you developers. So I figured that a lot of you probably don't know Gradle, or maybe just tried it a little bit. So I wanted to start with some basics and go through some simple projects. So if you look at a very simple Java project, first, the configuration is in a file called build.gradle that's located at the root of your project, where you would find your build.xml or pom.xml if you build with Ant or Maven. So with this simple line, what you can do is build your main code and generate a jar file, build your test code, run your test, and get two output. Some XML file that you can feed into your Jenkins server to get some trends and dashboard, and a local HTML report to get the same result when you're running your test on your workstation. The same Android project is a little bit more complicated, but it's not that bad really. So the first section, build script, is about telling Gradle where our plugin is. So we're saying here, hey, it's on Maven Central, here's the artifact, just put it on the class path. It's something that the Gradle developer want to improve in the future, so hopefully it will be a bit less verbose. Second, we just apply the plugin like we did for the Java plugin. And then the third block is really the beginning of the configuration of the Android plugin. And so we have two properties here. The first one, compile SDK version, is what you've used as target in project.properties. We renamed it because target SDK version, there was some confusion there. And then the second property I will talk about later. So what can you do with that? Well, you can build an APK. You can build a test APK. It used to be that we had a separate test project. It's just not flexible. We have to find it. It's awkward to find the relation between the two projects, so it's back in the main project. You can deploy those two APKs and run the test on any number of connected devices. It will run them in parallel, and you'll get the same two output, the XML and the HTML. So already we do more than the Ant script. So as you noticed, I didn't configure anything. It's convention over configuration. And for source folder, this is the convention for regular Java project. Because you have your main code and your test code, it's in the source main and source test. So for Android, we reuse the same convention. We expand it a little bit because we have a lot more files. So source main, we add Android manifest, XML, we add the resources, the assets. We move the AIDL and run the script files under their own folders. And then on the test side, we call that instrument test. We wanted to keep test for actual true local JUnit test. And we don't have a manifest in there. It will be automatically generated. I'll talk about that later. All right, so that's your structure. Now, how do you run the thing, right? Oh, wait, hold on. Sorry. So if you have an old project, I'm guessing that you probably don't want to go back to all of that, right, and change your project just to try Gradle. So this is how you configure a project that you currently have to tell Gradle, this is my structure. So here it's very simple. Again, in the Android block, we have a source set, and that's a container of source set. And so inside, we configure the main and the instrument test. So for instrument test, what we do is that set root will just move everything from source/instrument test to test, like so test/Java, test/res, etc. Notice how for the main source sets, we have res.source_dirs. And it's actually an array, right, with brackets. That's because we can actually now support multiple res folders. So you can just organize your resource however you want them, and then we'll just merge them together, detect duplicates, and do the right thing. All right, so to run Gradle, well, once you have installed Gradle, you go to your project root, and you just do Gradle and some task name. To get the task, there's a task called task that gives you the list of tasks. And if you do --all, it will give you all the intermediate tasks that you probably don't care about. And on a really complicated project, it's going to be 50 tasks or something like that. You don't care about all of those. You care about 4 of them. Assemble will build your project output. Check will run all your check and test. Build will do both assembling and testing, right? This is what building your project is. It's building it, but also testing it. And then clean does the clean. So the thing that's interesting here is that those tasks actually don't do anything. They're just, I like to call them anchor tasks. Plugins will go and kind of like plug them under it and say, hey, when the user says assemble, here's the task that you should actually call. So the Java project, for instance, has different tasks, jar to build the jar and test to run the test. So that means that when you apply, some other plugin like, static analysis, like, there's a find bugs plugin, you don't have to care what its tasks are. You just call check, and it will call test, find bugs main, and find bugs test. So it's very powerful and very extensible without you having to know what's going on. So for Android, we do the same thing. We have assemble, and then we have check, and then we have connected check and device check. And this is because of the test without device, test with device. I'll talk about that later. One other difference, assemble will actually build 2 different versions, right? We have the debug and release, similar to ant release and debug, except that here you can actually build both of them in parallel and have them built while ant would override each other. All right, so let's talk about customization a little bit, right? That's why we're building this new build system. So the most basic customization is, let's say you want to override some properties. So for example, here we have a default config object inside the Android object that says, hey, here I'm going to do version code and mini SDK version and something. And so when you build, those values will get injected into your manifest, and that's great. You're probably wondering, well, why do I want to do that when I can actually just put those values in my manifest? Well, imagine that you want to do a nightly build where you want to increase the version code incrementally. So you could do some script that goes in and somehow hack your manifest around and do something, and that's probably not very good. So here, Gradle allows us to just do something where you create a new function that will get that version code from from Jenkins, for example, through system property or environment variable, and then you just inject it into the version code, and that will work all the time. And then if the function actually returns -1 by default, which is when you're running on your desktop, then the value will not be injected. So you can do some custom logic, but it's still very declarative. I mentioned just a minute ago that we build debug and release, and a lot of developers have asked us things like, hey, I want to run progard in debug. Can I do that, please? And before it was like, well, we can't really do it. So we looked at it and we said, let's do something really flexible. And so we introduced the concept of build types. Build types are about how I package my application, and some options like, is it debuggable? How is it signed? Do I run progard? And you start with a built-in debug and a built-in release one, but you can create new ones. So here's the DSL to do it. So inside the Android object, you have a build types object. That's also a container. We saw that with source sets. We're going to see that again. It's a typical pattern that we have. And so in it, we configure the debug properties, and we set some property, the debug build type, and we set some properties, and one of them is package name suffix. So anytime you build with debug, whatever the package name of your application is will append .debug at the end of the package so that you can install it side by side with your release application. And then suffix name will, just a suffix also to extend. It's something that a lot of developers have asked us. And then, we have this new thing in Play Console where you can have a beta version, and maybe you want to actually build a specific beta version for those testers, and so you can create a new beta test. And so here we're adding some properties, and that's great, but that's not really enough if you really want to customize that beta version. So for each build type, you also get a custom source folders. So for example, in your beta version, let's say you want to, it's a beta test, so you want to gather some statistics on how your users are using your application. And so how do I do that? Well, under source/beta/Java, you just put some code, and that code will get packaged with your beta application whenever you build only the beta version, not the release and not the debug version. You'll probably want the internet permission to be able to send those data, and maybe your regular application doesn't have the internet permission. So instead of putting it manually in the manifest sometime and forgetting to remove it, which is not great, you just put it in source beta Android manifest, and that gets merged into your main manifest when you build only the beta version. And you can use that also for things like, if you have MapView API key and you want a different API key on release and debug because it's tied to your signing configuration, well, you can just put that into the rest folder of those different build types. And of course, you need to be able to build the beta version, right? So that's where the assemble, debug, and assemble release are coming from. They're just automatically generated whenever you add a new build type. So you can actually have all three versions at the same time and build them. All right. So I just said that signing was part of the build type configuration. So we wanted to make things very flexible here. We have a container of signing configuration, and a signing configuration is location of a key store, passwords, name of the key, and we have a default version one called debug. And so here what we are doing in that simple example is we are telling Gradle, configuring the debug signing configuration and using a key store that's at the root of my project. So that way everyone on your team or your build server will always build with the same debug key store, and there won't be any issue when your QA is trying to install something coming from a different build. And that's all you have to do. The debug build type is automatically configured to use that particular signing configuration. Let's look at another little bit more complicated example. Let's say you have a release version of your application that is different from your debug because maybe you have some properties that tell it, hey, I want to use my production server instead of some test server. I'm using progard, I'm obfuscating and doing a lot of things, and well, I want to test that version. I want to debug it. How do I do that? Well, what you would do, you would create a new build type, call it debug release, for instance. Init with will initialize it with the release build type. So every time you go and change your release build type, it just gets copied into your debug release. And then we customize something. So we say, hey, it's debuggable. We add a suffix to the package name to make sure you can install it in parallel with your release version. And then we assign the debug signing config so that anyone can build it. And then we change the source set to make sure that source/release, whatever you put in there, is also used to build your debug release. And just with these few lines, you suddenly have a new version of your application that's exactly and always exactly the same as your release, but you can debug it. And if you wanted to have some custom progard specifically also for that version to disable or enable some rules, you could do that, but by default, it will just pick up all the rules that the version used. What I really like about that example also is that it starts showing you that it's declarative, but init with here doesn't receive a primitive type. It receives actually a build types dot release. Right? That's actually an object of type build type. So what happens is that every time you inside the build type container, you start using release or debug or beta. If that particular object doesn't exist, we create a build type instance and we put it in the container. So what you're really doing here is not just setting a bunch of properties that will be read later on and by something that will parse that file and build something. We're actually, every line actually manipulates a live model. And that's very important and very powerful. That means that, okay, let's say you have, we have release, beta, debug release, that's a lot of them, and maybe you don't want to put the suffix, for the package name on all of them manually. What if you could just do it programmatically? Well, just do something like that, right? After the Android block, where you configure all your build types, just loop on the build types and just assign automatically the package name. What's really interesting here is that you're basically building that model, and that configured model is what is sent to the IDE after, during the IDE integration when you import your project. So whether you're setting those package name suffix manually or whether you're using some logic, a loop, or maybe you say, hey, I only want to add them on Mondays, whatever you're doing, it's just going to work. The IDE will just be aware of what's going on because it gets the final configured model. And that's very powerful. That allows us to really have the IDE know everything about your project, based on that model, however it is, whatever logic you use to actually configure it. All right, let's look at dependencies. It's something that a lot of developers have asked for. So Gradle supports that natively, so we benefit from that. So there's 4 scopes of dependencies. Compile, runtime, that's for your main source code, and runtime always extend compile. So if you add a dependency to compile, runtime automatically gets it. And then there's the same for test. So for Android, slightly different, mostly because we rename runtime to package because it's what we really do, right? We package all of your dependencies into the APK. And then test, instrument test to make sure that it's always instrumentation test. So let's go back to your test, to your beta version, right? We want to send the statistics to the user. Let's say you want to use some library to help you. Well, if you add them on compile, that means that your release will also have that library, and you don't want to do that. So we have scopes specifically for your build types. So here, only on the beta compile scope, you would say, hey, I use protobuf or something like that, and then it only for that build type. So this is how you do dependencies in Gradle. You have a dependencies object. Compile is the scope, and then you give it whatever dependency you have. Here we say, if I have an old project and I have a bunch of jar files under my libs project, that's what you do. File tree, every jar file under libs. Very useful to migrate your current project. So if you want to use remote dependencies, this is what you do. First, you tell it what repository to use. So here we say Maven Central, but you could say, if you have a custom internal artifact repository, you can put the URL there. Whether it's Maven or Ivy, it will support it. Not a problem. And then in the dependency block, the instrument test compile, you give the artifact address, and here we use the fast Android from Square that allow you to have some nice assets and test output. And then notice how the beta compile uses a local jar, right? So it's not, I want to use either dependency management with Maven or local jar file. You can just mix depending on what you have. Gradle is very flexible. It will use whatever you want. So that's about using someone else's code. If you want to use your own code, it's slightly different. First, you need to have a multi-project setup. It's something that we didn't have before. Eclipse doesn't really support that, and doesn't, of course. So here, what we have is we have 3 different package modules. There's ab, lib1, lib2. They're all their own project with their own build.gradle, and there's settings.gradle that say, here's all the different modules. And for the dependency, you just say, hey, I want to include the project and the path of the project. So that's very similar and very easy. So library 1 could be a library project, and then lib2 could be just like a jar file. And if lib1 depends on lib2, of course, app will get transitively all the dependencies. And so if lib1 is a library project, this is how you declare a library project. It's exactly the same as a regular project. It's the same plugin. You only need one plugin. It has both package, well, only one Maven artifact. It has both plugin inside, and the plugin name is different, but it's exactly the same as a regular project. The DSL is slightly different because there's some restrictions, but I'm not going to go into detail on that. So what do library projects do? Very similar to what they currently do. We have some new things. The first thing is that finally we have binary packaging of them. So we package everything into an AAR format. It's just a zip file. It's a bundle. And you can upload that into repositories. Yes, it's been a long time coming. Other thing that we support, we have support for assets. So just put assets in your library, they'll get merged into your application. We have ProGuard rules. So if, for example, your library has some specific class that should not be obfuscated, just create a ProGuard file, keep that particular file. And whenever the application that use that library runs ProGuard, it will also enable that ProGuard rule so that your class don't get obfuscated, for instance. We don't have lint integration yet, but as soon as we add it, we want to do things like custom lint rules, so that if you have some custom APIs that you want to make sure people use properly, you can have some rules there. And we're looking at adding other metadata so that whoever uses your library, they have a better experience in the toolchain, in the IDE, and it's better for your user. All right. So library projects have been used for people who want to do free versus paid and things like that, and it's great. Now, multiple APK support in Google Play also allow you to do, for example, different APK for if you're targeting an older version of Android or a newer version of Android, or if you're targeting ARM versus MIPS versus x86. But if you want to use all 3 or a combination, then it becomes impossible to deal with library project. And so we have build variants. So this concept of product flavor is about what is your application, right? So it's going to support different applications, whether they have the same package name or not, depending on free versus paid or not, and it will allow you to customize things. So it's really like a different dimension from build type, right? It's combined with build types. So here's how you create them. We have a product flavor containers, and you can just create new ones. So here I'm creating 2 flavors, flavor 1, flavor 2. I'm assigning some packages. One of them say, hey, I want a different min SDK version. The other one will use the min SDK version from the manifest automatically. And of course, you want to have different code in those, right? The free version will have some code specifically to free and the paid version to pay. So for each of those, you get a new source folder as well. And because you want to test it separately, you get a separate test folder as well. And if you have a free version that's supported by ads, you want to add some, I don't know, like a dependency on AdMob's SDK, for instance, but you don't want to put that on the paid version as well. So you have a different scope. So here we'll have a lot of scope for all your applications. And basically, based on what you build, we pick all of them and put all your dependencies together. So the part that's important is that if you don't have any flavor and you have a debug and release build types, you get a debug and a release application. If you have flavors, then it's really a matrix, and we do a combination of everything. So if you have a flavor 1 and flavor 2, then you can't have just a debug build. It doesn't mean anything anymore. It's either flavor 1 debug or flavor 2 debug. So that's very useful if you have free versus paid. Now, if you also want to combine x86 versus MIPS versus ARM, well, that doesn't really work, right? So we have flavor dimensions, right? But we call them groups in the DSL. We might have to rename that. So it's really a different dimension compared to, so one dimension is ABI, x86 versus ARM, and the other one is, the version, whether it's paid or free. And so here we create 2 ARM, and we assign them to a specific dimension. So note how the ARM one doesn't customize the package name, right? That's because it's just the same version of your application, while the paid version has its own package name. So there's going to be some combination of all of that. First, at the end, you get a lot of packages, and you just get them automatically. And if you add a new dimension or add something, we just take care of generating all of that for you. And so because it's complicated, you need to understand the different ways we combined all of those dimensions, right? Build type, and different dimensions of product flavor. So you could get up to 4 different source folders, for example, in that particular example. And so they're all going to be considered as if there was just one source folder, and we just combine everything into a single APK. If you have resources, we just use override mechanism. So we start with your base resources. We override on top of it the flavors, and then on top of that, we override the build types. And that's for res and for assets as well. And if you have libraries, right? If you have libraries, that will be under the main one, and they will be overridden by all of that. Signing configuration, here we have some flexibility. It's a priority order. So highest priority order is build type, and then flavor, and then your main configuration. What's interesting here is that the signing build type has the debug build type as the default debug configuration. And so every debug build type will get signed with the same key. For release, if you assign a signing configuration on release build type, all your release will be signed with the same key. But if you don't want to do that, maybe your paid and your free needs different signing key, then don't assign a signing configuration on the build type and assign it on the flavor instead. And then it's the one that will get picked up, and you can have different signing for 2 different versions of your apps. And then the package name, so you saw that we have a lot of ways of customizing package name. So we start with the base Android package name in the manifest. If you have a default configuration that overrides it, we take this one instead. If you have a flavor, we take this one. And then when we figure out which package name you have, if you have one in the build type, we append the suffix. But when we generate the R class, we always use the package name in the source main Android manifest.xml so that all of your import, wherever you are always the same one. There's no switching. You can generate many applications with different package name, but all your imports are always the same. OK, let's look at testing. I mentioned testing here and there, so let's do a quick recap. You have source folders for testing and one per flavor if you use flavors. You have scopes, one specific dependency scope, one specific for testing and one per flavors. We generate the manifest. I know you probably understand why we generate those manifests, since if you generate 6 different applications with 6 different packages, you don't want to maintain 6 different manifests for your test application. The manifest for the test application actually reference the package being tested, so that would be a lot to maintain. And for the package name of the test application, we generate that automatically based on the package name of the tested application. And we're going to have one test app per tested application. So right now, we only test one build type. So debug by default, you can configure it. We'll probably change that in the future. But Right now, it's just one. And then finally, library project, even though they output just an AR, not an APK, we can test those. So inside the library project, you do have the, one of the output is the test APK, and it will embed your library into it. So you can test your library separately and inside your APK also if you want. All right, so that's about building, right? What about running tests? So that's a little bit complicated, and we looked into it, and we found out that there's really like 3 different scenarios. The first scenario is, I don't have devices, I just want to test something, right? So, and we link that to the regular check task from Gradle. So, you're going to be limited to what you can run there. You're going to be able to run static analysis, like either find bugs and or lints. And if you use Roboelectric, well, you can run them there too, right? The second scenario is, I'm a developer sitting at my desk, I have my phone connected to my workstation, maybe also a tablet. I want to run something, so that's what connected check is. It will just look for connected devices, run everything on it in parallel, just give you results. Okay. Third scenario is your build server. Well, here you shouldn't really have devices connected directly to your build server. Several issues. First, well, you may have more than one build server, so that's a problem, right? You're going to need a lot more devices. If you do build in parallel, you can't run instrumentation tests that hit the UI in parallel because that's just not going to work. So you would need to have some sort of queue, right? So we looked around, and there's really like 2 different scenarios there, sub-scenarios. So the first one is you have a device lab somewhere, and you have a queue system, and your build system just build something, and then it gets put in the queue, and you have devices, and you test that. And well, you're going to get a remote dashboard, right? Because it's not going to be your Jenkins instance running your tests, so you'll get a different dashboard. But that will work. So one thing that we think is important here is that you don't want Jenkins to, after your build, say, hey, what's the output? I grab the output and I upload it somewhere. Because Jenkins doesn't know about all the build variants that I just talked about. So you want to have the build system who is aware of that actually do the push. So that whenever you add a new build variant or remove one, you don't have to go back and configure your Jenkins instance. So we created an API. We call that test server APIs. And it allows you to upload an APK somewhere. It's very easy to implement. And so if you have your own testing lab, you can implement it. If you don't have your own testing lab, well, there's services out there that do that. TestDroid is one, AppThwack is one. Both of them are on the sandbox, so you should go and talk to them. And we're going to work with those guys to make sure that they create a plugin and we integrate with them. The second scenario is, well, what if you have access directly to devices or emulators? It's generally going to be emulator that runs directly and on demand. So here we have another API. It's very simple. We get the list of devices, and for each device, we connect to them, which in case of emulator is really going to be just starting them. Then we install, we get the test, we drop them, and then we have actually a local result. And there's different companies doing that. One of them is Manimo. They're here also on the sandbox, so you can go and talk to them. Or maybe I can show you, actually. We worked with those guys, and we created a plugin. So let's look at what that looks like. So here I have a sample project. It's very basic. I have a build.gradle here. So we applied the Android plugin right here, and then their plugin. So what that does is basically their plugin, upon being installed, automatically find our plugin and say, hey, I'm implementing that extension point, just go there. And then, because it's a Gradle plugin, it can also have its own DSL. So here we have a custom DSL that say, hey, I want to test on those 2 devices. But they have over 50 different emulator configuration, and so if you don't provide any device, it's just going to say, I want to test on all of them. So it's going to get the list from their server, find the ones that are compatible with your application, depending on your mini SDK version and things like that. Well, right now, only mini SDK version, but later, ABIs and things like that. And it will just run all the tests in parallel. So here, just to be, for it to be easier, we're just going to test on 2 different ones. So the first thing I want to show you is when you get the list of tasks, because we know that there's this, extension point. There you go. So we have here, automatically a Manimo instrument test method. And so, every time you have a new service provider, we have a new task for it. But we're not going to call it. On your build server, you would directly do Gradle, device check. I'm going to do info here. And so it's going to build the application, which actually doesn't need to be built. So it's going to say up to date, up to date, up to date. And here we start building. say, hey, connecting to that emulator. And so my device is not starting any emulator here. It's actually connecting in the cloud. It's starting the second one. And then it's going to deploy, hey, I have a test that succeeded. And it's shutting it down now. And then I have another test that succeeded, and it's done. And that's it. I just tested on 2 different emulators in the cloud. It could have been 20, 50 in parallel, super easy to do. And then you just go and you do open, build, reports, test device. And you have a report per provider, index.html. And you have your test. It's tested on those 2 devices. You can look per device, and it's there. Super easy to do. We really want to improve. There we go. So we really want to improve, the experience of testing for Android, and there's a lot of things that go in there. There's, helping you write tests, and we need to work on that. But running them is a big part of it, and working with company like Manimo. So again, they're on the show floor. They actually have a special offer for IO attendees, so you should definitely go and check them out. Integrating with third-party services or making it easy for you to integrate with your own system internally is super important, and we want to make sure that it's super easy for you to use. All right. The last thing I want to talk about is build environment. So we know that in the past, we've regularly updated the tools and somehow broke your builds. You get a new version of ADT and nothing compiles anymore, and it's a big problem. And we want to fix that. We want to make sure that this doesn't happen again. And Gradle is really going to help us do that. There's 4 key points to that. First, you're in charge of the Gradle version. And we were already in charge of the Ant version somewhat, but Gradle actually, they add new features so quickly compared to Ant that it's good that you're in charge. And they have this feature called the wrapper that makes it super easy for you to really control the fact that every developer, every build server has the same version of Gradle. It's a really sleek tool. Really check it out. All right. Second point is you're in charge of the build of the version of the plugin. So you saw in the DSL right at the beginning how I say, hey, get the plugin from Maven Central, and here it is. Well, part of the artifact address is the version number. When we update a new version, we're not going to remove the old version, so you can always stay on an older version, and it's up to you to switch when you're ready to switch. The second point is that property that I didn't talk about also at the beginning. So the plugin used some tools like apt to compile the resources, dx to compile the bytecode into Dalvik. And it used to be in the SDK under a component called platform tools, and there was only one version of it. And sometimes when you update the tools, it forces you to update the platform tools, and so suddenly, hey, it's updated under you, and you don't have a choice. So here we move that out of the SDK platform tool component, and we create a new component called build tools. And the big point about build tools is that you can have many of them in the SDK. So imagine a case where you have you have an SDK, you have an old project that you don't want to migrate because it's fine the way it is. It's using an old plugin and an old version of build tools, not a problem. You want to start a new project, you want to start fresh, you use a new version of the plugin, you use a new version of build tools, and you have 2 different projects using 2 different tool chains from a single SDK. And then finally, the fourth point is that, well, the IDE, I mentioned that when we talked about Studio on Wednesday, the IDE doesn't do a build anymore, right? You import Gradle project, you delegate to Gradle project whenever you do build. So, before when you updated the ADT, you would get both inside the same plugin, a builder and editors. Here, Studio is all about editing and debugging and profiling. It's not about building anymore. So, feel free every time we release a new version of Studio or of ADT when we integrate Gradle into ADT, which is coming. Feel free to get the new version because Gradle, it's only when you change those values in your build script that you will force yourself to switch to a new version of the build. All right, so this is a very short introduction to the build system. There's a lot of information online at tools.android.com, a lot of documentation and more details about configuring the build. Like I mentioned, the DSL for the libraries is very different. So you should check it out. We need your feedback, right? We want to make sure that it's as flexible as it needs to be for all of you. I think we already have a lot of customization, but I'm sure there's some things we're missing. And so, give us feedback, try it, especially with Studio anyway. You have to try it. So that's why, we're very happy. And just give us feedback, file bug, and we'll do whatever we can to improve things. So actually, it looks like I do have time for questions. So thank you. So I will be after, anyway, in the sandbox upstairs to answer whatever questions, but we do have time, so I guess we can take some questions.
So you mentioned that I believe you had compile and release dependencies or runtime dependencies.
Yes.
You guys have different names for it. How is Android.jar treated?
I'm sorry, Android.jar?
Yeah, because it's like a build-only dependency.
So it's done automatically. You don't have to do it. In your DSL at the beginning, when you say compile SDK version 17, it just picks the SDK version from 17.
So can you add a hook for that? Is it possible for you guys to add a hook for that?
I'm sorry, do what?
Well, some of us are compiling against custom versions of Android.jar.
Well, you probably shouldn't be, but
Some of us are.
yeah. And we'll have to figure something out,
Okay,
I guess. Right.
Hey, first, thank you. It's a lot of stuff. I have two questions. One is about library projects, the AAR. Do they each have their own r.java, or does the whole app have its own r.java?
So AAR has, I'm sorry, can you repeat?
So can library projects have their own resources?
Yeah. Resources, asset. So the AR is a zip file. In it, you have classes.jar, that's your compiled classes. It has your manifest in case you have activities, permissions and things like that. It has resource folder, assets folder. It has a progrart file in case you have one. Ultimately, it will have JNI libraries if you have them, linjar, whatever else.
Okay. Thank you. And the second question is about NDK integration.
Yeah.
You had a couple of things that are about x86 and JNI.
Yeah. So we don't, damn. So I do mention the whole x86 and ARM, and that's the design of it, but we don't support the NDK right now. Okay. So that's coming very soon, though. So you'll be able to build directly. Gradle will call out to the NDK. It will, we'll have a way of configuring in a build type which ABI you want to use, either all three if you want to do a fat package or just one. And then it will call out to the NDK saying, hey, please build the ARM version and put the result here for that build type, build it for another ABI and put it there for another build type. And so that's how we're going to do the filtering. Really.
And will that be integrated into Android Studio also, the NDK building?
Yes, so it will be part of Gradle, right? So whenever you build with Gradle, if you say, hey, I want to build some native stuff, it will build it. And Studio will technically not care about it. At some point, we'll have to add editing features for them. That's going to take longer, but at least you will be able to edit your files and just make it work. And
so where can we see details of what's coming for NDK? Do you
we don't really have any roadmap planned at this time.
Okay.
Or, we do have some plans, but we don't have anything written down. All right.
Hi, my name is Mark. I would like to know that, so now we have many folders like src, Java, JNI, RS, asset, and so on. And the merging process of these folders, are they different? Or what I really want to know, can we have dependencies and assets? So if we have library process with the assets in it, right now it's not built into the final APK. Is that true for the new one, for the Gradle build?
Yeah, so if you have assets in your library that will get packed into your package, you can have assets, per flavor. Every flavor, every build type, has its own Java code, its own manifest, its own resources, its own assets, and depending on which flavor you're building, it just picks up and merges all of that, together automatically. And libraries are picked up automatically and merged, and it's.
Thanks. I waited a long time for that.
So, since you're not supporting NDK, how about Ant? Is that still going to be supported for time being?
Ant is going to be, I guess, deprecated. I would recommend moving to Gradle as soon as you're able to. If you're missing features.
You're not supporting NDK.
Oh, support for the NDK?
You just said that you're not supporting NDK.
Yes.
At this moment. So, the only way to build it, well, not the only, but.
Well, right now, the NDK doesn't build with Ant either, right? It just make files.
Yes, but it's easy to integrate.
Yes, but that's not the future. It's like, we're going to keep the make files inside the NDK anyway. so you can call it manually if you want. It's like, the problem with the AND stuff is that, it's a mix of, I have some script in the XML, we have some custom code, because whenever we have some really complex logic, like combining all of those source set, assets, res, all of that, you can't do that in XML. So we have custom tasks. I re-implemented, a quick if-else, statement in the custom task to be able to use it in my XML. But it's like it's a mix, and we pass a lot of things to the custom task, and then back to the XML, and back to another custom task. It's just a freaking mess. It's just we can't maintain that, and I'm happy to let it be whatever it is when we switch to Gradle, but we're not going to improve it. It's not going to work from an IDE. It's just not, it's deprecated.
Sure.
It will be deprecated. But I mean, it's open source. Take it. Make sure that you have a version. If you really want to maintain it. But we are not going to keep maintaining it. And the goal of this build system is to have a single one that works everywhere. So I'm not going to keep maintaining also another one. Although right now I am. But when we switch to 1.0, we're not anymore.
Hey Cyril, my name's William. I've been using Maven to build up until now, so it looks like I've got to change the way I'm thinking about things. One of the things that Maven does really well is you can go and release your APK at the end, and it handles all of the versioning and make sure everything works all right. How's that going to work in with Gradle?
Wait, sorry, can you repeat that?
Gradle doesn't seem to have the release mechanism that Maven does, where when you want to go and release a version of your APK, it handles the versioning, interacts with your source control mechanism, does all the build for you, updates source control, publishes to your artifact repositories, etc.
Yeah, that's probably more like a question for Gradle itself than our plugin. Gradleware, they have a sandbox, and when I take questions, there will be people from Gradleware, because it's more like the whole workflow behind releasing, and Gradle, I'm sure, supports that. Yeah, we'll do that upstairs. We'll take that question upstairs.
All right. The other one is APK libs, which are pretty common imports now.
So the Maven plugin will switch to the AR format. I'm looking to supporting APK lib, but I'm not sure if that's going to happen or not. Okay. But they're switching to AR, and I know some libraries are going to publish to AR already. So I know I talked to Jack Wharton, Action Bar Sherlock at some point. They're going to distribute AR, so you'll be able to use that.
So we'll be able to, for our plugins which we intend on, our libraries we intend on publishing, we'll be able to create an AAR as an output?
Yeah.
Okay, cool, thanks.
All right, thank you. So I'll be upstairs. If you have more questions, feel free to come and talk to me.